Nice. Oh, we need to mute these things. Cool. Kubo. Hello. All right, I think we're live. Cool. All right, well, I'm Tony, if you don't know, from my name in the descriptions, also known as Birdworm, various interweb places, Twitter, Hacker News, GitHub, all that jazz. Today we're going to be working on, I think we need working on, I don't know if this is going to be easy to read through the stream, but if you go to docs.hofstadter.io, it should be in the, oh, wait, we need to get the right, there we go. Cool, all right, there we go. Now we're set. All right, welcome. As you can see up here, got GitHub Verbworm. This site is docs.hofstadter.io. This is the main thing I work on. It's a code generation platform, low code for developers, or like we like to say, high code. And the other main thing, I'm on the wrong screen. And this is powered by qlang.org. This is the main language that I've been working with for almost 2 years now. So what I've been working on is, well, not getting started. You can go through getting started. You can install if you want to follow along. Test, and the tool can self-update itself once you get one copy. We have, oops, I'm doing this wrong. I got two computers going on. As I said, we use Q. Join the Slack. You can join Hof Slack here, and you can find your way to the Qlang Slack through community here. Both great places to come find me. We got some concepts for Hoth, like a single source of truth. That's what you write Q in, and you write like designs for applications, servers, command line utilities, and data models. And then you generate code, and you can regenerate code, and you can work directly in the output, and then change your design and regenerate the code. This idea of polyglot modules. So you write some Q, it gets pumped through a generator, which is really just a collection of text templates from Golang that Hof has written in Go. And then it renders those templates and writes them out to disk. So it doesn't really matter what's in those templates. Like you put anything in there. So the idea here is two ideas really for polyglot modules. One is that it can incorporate a number of technologies within a single module, and then also that you can like compose different modules and generators and schemas together. And there's total customization. Like you can customize the tech you use, you can customize templates, you can customize the code in the generated output and add your own as much as you want or as little as you want. Like if you're writing generators, there's a lot of flexibility in where you decide to make that trade-off. And I'm clicking on the wrong window again. So yeah, we got these commands. Hofmod is for managing these modules. We can create a module, and then we can vendor. We have to make a file like, Go mod has a file, and then Hoff mods is a generic version of Go mods. So it should work with any repository. And you can create your own quote unquote module systems where you have your own like foo.mods or whatever. So we make that. And then we have generate code. So, Hoff-gen, we just generate here, and it's actually like writing code. But you can't see that. It writes out all this code in this whole directory. Actually, everything under command, as well as gen for some config. Anyway, we're going to see more of this, because today we're going to try and write a SQL module, which will mean we're going to getting ahead of myself, or maybe I'm doing an introduction when I was not intended to, but I've been working on this HoffDM, or data model command, so we can list different data models. There's a bunch of different things we do. The big thing is that we can checkpoint a data model, and we start creating this history, and then we can calculate diffs across that, and we end up actually feeding all this into our templates as well. So I've been really working on this first example where we're building a simple server. And this section walks you through just like getting a directory set up. We have a schema, and typically we're writing a generator. So we have a schema and then a generator definition. And then the templates, partials, and statics, and some other things can be fed into the generator. Along with, this is the examples, is like what a user of your generator would write. And so then we feed that back into the generator through the schema to verify that it's like following the rules. It's done as a module, so this shows you how to get set up. And then there's a schema. So we have a minimal schema here, and it's just a queue definition. But so we're going to call this our schema a server, and it's going to have a name, description, a help string, something like that. And these are just kind of like basic common fields to probably any schema. But for a server, we're going to have routes and handlers. So we have HTTP methods, and then we have a series of routes, and a route is just a list of route, and a route is a name. Name is used through a lot of these things just to like act as a unique identifier, at least within a level of the scope. But a route, like any HTTP route, has a path, it has an HTTP method, it can have path params and query params, and then it can have subroutes. And then what this here is for the generated code. We could write the body of our route handler directly enqueue if we want, or we can write it in the generated file. And then this is just to add like imports to that. If you want to like write the body here and you need imports to support that, you can write them here and they'll be injected in. And then you can imagine having extra features, such as the ability to embed files into your server. And so you give the user the ability to specify globs, and all those get embedded. So like with a server, you might want to include the HTML and JavaScript directly in the binary, which is something you can do with Go. Or you want to turn on Prometheus. And so you want Prometheus metrics, so you just say true. And in the backend, there's a whole bunch of stuff going on. Then we can calculate fields from other fields, so we can work with different casings of the name. And then we might have specific language fields. And if you want to look at the full schema, it's right there. It's not too long. Much more concise than something like a OpenAPI or JSON schema. Anyway, then we have a generator. And this is the definition for host generators. So any generator is going to abide by this schema here. It has an outdir where it's going to write the code, typically right where you are, but for our examples, we do it a little bit different. And then every template gets an in value, which is something that you have to provide as a generator writer to Hoff. Whether or not you expose this directly to your user we'll see in a bit, it's either or, however you want to do it. And then we produce a list of out files for Hoth to generate, and we'll see the schema for this below. There's also templates. These are Go text templates, and then partials for those, and then any static files that don't render or go through the rendering engine, they just get copied right over. And there's some other fields we'll see later. And then you can always add whatever fields you want to this. So then a Hoth file has its own data, so you can have local data and then generator-wide data, and these get merged together if this is optional for the file. So then it's going to have a file path where it generates, and typically we figure out this name by interpolating based on the input data. And then you have either template content, a literal string of the template content. So you could, if in theory, write a complete application in Q and then generate it out with Hoth. Or you can separate out the templates from the Q code, so you can write them as independent files. And this template path is a lookup into this template set up here. So yeah, we're mapping essentially ins to outs. And so our server generator is now an instance of what we just saw. We're going to provide a server value for users to set, and we're going to set that to our schema server from the previous section. And then we're going to provide outdir, and we're just going to keep the default definition so that they can then set it to where they want as a user. We're going to make the user add like the name of their Go module, because this is a server in Echo framework, Golang, a Golang module for building REST servers. And then we construct in ourselves. We don't really, well, the user could set this, they shouldn't, and we just really make an uppercase so it's easy to identify in the templates, and then we rename Go module to module. And then we have our out. It's just a, just it's all. We just do this for convenience. We have a bunch of once files that are generated once for every server, like a main.go, a router that wires everything up, middleware, and then we have route files. So for every route, we're going to generate a file. So our once files, we have a mod, we have the server.go, router, middleware, like I was saying, and then for each route in server.routes, we're going to construct an in object, and then we're going to use this route template, and we're going to generate under outdir routes and then the route name.go. And there's a bunch of other stuff that gets more advanced. We'll see in later sections. And then we have templates. This is the back end of a generator, the real implementation. We need to remove that. We removed that. So essentially, here's our Go mod. It's the module and our module name. And we'll say Go 117, and we'll set the versions that this module is working with. Then we have our server.go package main. Again, this is the framework we're using. If you look them up, there's links in the doc somewhere. There should be back here maybe. Yeah. No. I don't know where I put those. Maybe they need to go somewhere. Anyway, back to templates. Sorry. Server.go. We started a new Echo server, hide the banner, set up middleware, set up the router. And then we have this is something really cool, right? Like the Echo's hello world doesn't have this advanced capability down here. And what this essentially is, this section all down here is how we do graceful shutdowns of the Echo server in Golang. And so we essentially, in a coroutine or a Go func, a Go routine rather, we kick off the start on the port, and that will return at some point. And when it does, we're going to say shutting down the server. So then this is running in the background, and then we create a quit channel, and we get a signal from the operating system. And then what we can do is we wait until we get that signal. And when we do, we then with a timeout of 60 seconds over here, we create a context with timeout, and then we tell Echo to shut down here once we get that. And so this is our like sync point. We're waiting for something here, and then we shut down. And this does the graceful shutdown, waiting for connections. Unless the 60 seconds run out, then this defer will cancel the context and everything will fall out of the program, and you might have some dropped connections. Anyway, then we have a router, right? And we need to set up router. So what we do is if we have any routes, we import the routes, which is pretty much always going to be the case. So you might just hard code this, but we're making it flexible. And what we do is we have a default route alive. It just returns no content 200, so that something like Kubernetes can have it make an alive request just to see if this thing's responding, which is different from like, am I healthy? This is just like, am I responsive at the most basic level? And then here's our Prometheus. We create a Prometheus handler, and then we get all these metrics out. And that was just a bool for the user. And then we create a group for all of our real routes, or our application routes, I should say, that are interesting to the user. And for each route, we're going to call into that route's name this routes function, which is just below, 2 files down. And what this does is just you pass in this G for the group, and it attaches itself to it. So instead of like attaching it here at the top level, at each route we've written a function that wires itself up given a group. And then we have some middleware, and we have recover, logger. Again, then we inject our Prometheus middleware. So we have a route for the Prometheus and then middleware for the Prometheus. Still, again, just a single Boolean. And then routes. So this is what a route looks like. It has a func named routes. This is what we just called from the router setup. And so it's going to create its own group based on its path and any params it has. And then whatever method is, this is just, I think we have some rendered content below, so we'll see it in a second. I should maybe make these tabs. Anyway, I digress. So this is just the wire up function, and then here's the actual handler. And here we're using a partial. And all it's doing is like using the route as context, and then we're going to call it route name.handler, and then we check any params or query params, path and query params. We pull them out into variables. And if there's a body, we write that custom body. Otherwise, we write this default body of not implementing, and we return nil. And so this is where you can do whatever you want. So rendered files, right? Here's our middleware. We're not showing everything because some of them are, if you look at something like this, there's not really any template in here. We have it in the templates because it will get templated values down the line. So then rendered files, right? We're setting up the middleware. This looks, because we set Prometheus to true, here we go. Here's our router, right? We see these same functions, and then we see like we have 3 routes. Did we show the actual data? Oh, maybe it's on the next page. Maybe these are out of order. And then here's a handler. Here's the hello handler. We're setting up this group off of the group that comes in. We create a new group, and we call it the hello path. And then we attach our handler to that. And again, this has a query param message, and if it's empty, it just returns hello world. Otherwise, it's just going to return essentially the message back. All right, so then using this is the server design that just generated that rendered content. Name is example, and example server. We have 3 routes here. Echo, which has a query version, and then we have a path version of Echo. And then we have the hello we just saw. And then here's our Prometheus true. And then our servers, and then this is how we use a generator. Notice we're importing the generator from our first example. And then this is a little markup. So Hoff will look for anything with the @gen. And then if you supply some flags, you can reduce what you generate. So if you're generating front ends and back ends with Hoff, and you've only changed stuff that impacts the front end, you can just generate that. And probably hot reload code, because you can run hot reload on the output, and actually the client module has the hot module reload set up. In this case, we're putting in an output dir, so it doesn't conflict, because this is in our example within our module. If you remember, there was an example folder for our generator module where we show users of this an example of how to use our generator. Again, a Go module. I guess we don't need that. Let's duplicate. Proofreading some docs. And then here's where we pass in this server design to the generator. Remember, there was that server field that ended up in the what you call it, in. And as a generator writer, when you're writing examples directly in the same module as your generator, when you write a generator, you have to provide a package name. So we have to turn that off when we're writing an example within the module that we're authoring. Outside, like this is the user doesn't even write this kind of stuff, so we can get rid of it. But I didn't want to like deal with like cross directory modules and all that and importing it this at this point. And then so that's all set up. Then we just do hoffgen example. Hoffgen takes as its arguments same thing as Q does, the entry points for where Q should start processing, and then it'll put all this stuff into the output. And if you want to see the code for this, you just go to GitHub, go into Hoff Docs, the repository for this website. So if you want to run Hoff Docs locally, you can do that, and you can find all the content under here. And then like first example, as these directories were in simple server, the code section mirrors that. So here's our simple server, right? Here's our example code, those files we just saw, and all the other things. You can like cruise through that and check it out. So then, yeah, we generate, and then you can run the server. It runs right out of the box, and you can talk to it. There might be one issue with a query param that's not used, but we could fix that. So that's the simple server, just like taking you through some basic motions with Hoff. I think I've just finished this yesterday or the day before. This is about adding data model, that Hoff DM command. And like we had a Hoff schema. Where did it go? Here it is. We have a generator schema for Hoff. There is also a schema for data models, and its most basic form. You have a data model. It has a name, and it has a bunch of models. And a model has a name, has a bunch of fields, and maybe some relations to one another. And then fields have a name and a type. And relations have a name. They have a relation class, and then they have a type they're referring to. This is more like the type in like Golang, like string or bool or whatever, as a string. And then this type is a reference to another model. Maybe we should call this, I don't know if I want to call it model, but we can't actually put the real reference to another model here because we get cyclic relations and queue bugs out, kind of a thing. All right. So then You can see the full schema here. That'll take you to another page. I won't go into that. So we have, so what we can do with the data model, like we can with generators, we can specialize generators. We can specialize data models. And so we're using the Hoff's default most abstract schema for a data model, this thing here. And what we're gonna do is like, we're gonna override our model. And what we're gonna do is we're gonna add an index field. And all this is gonna hold is the name of another field that we wanna use to index with. And in this case, for this example, we'll see we're not using a database, we're just using a Go map interface for holding our data model, which we're gonna have it's to-do application user and to do. And then we have an ordered models. And this is something you'll probably do pretty often, to the point that I'm thinking about putting the abstract one, but essentially all of this is a consistent order. What happens is, from the translation queue to go to the encoded data for the template, you can get inconsistencies in order of models because it's a map rather than a slice when this turns into Go data. And we need this for things like migrations to make sure we have the right order. So Q has a consistent order internally, but what the translation into a Go data, once it's in a Go map, like, the order is not guaranteed anymore. And that's just a nuance of Go. So we want to generate types from these data models, right? So we're going to create a generator for types. And it's going to take our schema that we just saw. It's going to build on a Hoff generator. And I should probably make this more clear. This is actually, so adding a data model. This first example, like, we had a snapshot here in code. Like, if we look at first example, simple, adding a data model starts where simple server did and just picks up. So this is our server. We're going to add types that we can read and write in our API server. So this was our original server generator. This might be the wrong name. No, it's copy file. This is the server generator. And so we had the server before. Now we're adding data model. Here we can look. I'm just showing the change set. If we look at this at the same time and we go to generator, server.q, you'll see here's server and data model, right? And so what we're doing is we're just going to add this to all. But we'll actually end up with something like this. Probably need, this comes later. We'll add this one later, but for now, you could just imagine these three. You have to write them all explicitly. You can't just put this next to it because of Q. If you're not familiar with Q, we could talk about Q another time. I'm not going to go into the details necessarily, other than that, this is a list, and we're just copying this list into this list, and what you see here is really just a way to combine multiple lists into one single flat list and then present that to Hoff. So we come back here. So type files is a lot like our routes. For each model in our data model, we're going to generate some in, and here we're also going to order the fields. This might also be pulled up into the top level schema. I should think about that. And we're going to use this type template, and we had route here before, so we put all our routes under a directory. We're going to do the same thing with types. So all the types in our application will live in a single directory. In theory, you could add as many directories here and organize as you want. There's a lot of things you could do if you're writing your own generators. So now we have our generator set up, and I think, in the previous section, we added to our schema down here, or we extended the schema. Now we got our generator set up, we expanded on our generator. We injected these fields into the existing one, so it's much longer. And this is the template for a type. So here you have a type struct, and we're going to range over the ordered fields and just do name and type. We're not getting fancy here. We're just going to make sure that users, write the right type in there. We can provide a whole bunch of checks in a much more sophisticated setup, but we're going to sort of omit a bunch of that kind of stuff. And then we have this type name map, which is just another type of a map string, a pointer to one of these structs here. And then we're going to make a variable of this map right here to act as our store. We prefix a lot of things by the name because they're all landing in the same directory and they need unique names. You could, in theory, put this under its own directory. And then when we're going to write an init function, so when Go starts up, it's going to make sure this map is at least alive and ready to be used. And then we're going to, not only are we going to generate a type, but we're going to generate some functions to go with it so that we can create a function or create an instance of this. And we're just, if we pass in this, it's going to put in the store. So this is a library around our data store. And so you could imagine replacing this initialization up here with a database, and these calls with calls to the database or some SQL. So, and here's a cool thing. For every type, we're going to get something that checks if it's there, and if it's not, it's going to store. Otherwise, we're going to turn an error. Same thing for read. And we can update an object. We make sure it's there before we update, where here we make sure it's not there before we add it. And then we have a delete function. And so you could regenerate the server. I don't think it will be doing much at this point because we haven't added API based on this data model. So that's what we're going to do next. We're going to create API resources, and the concept of a RESTful server has resources that you can do CRUD against. Create, read, update, delete. And so what is a resource? Well, resources is just a map of resource. And a resource has a model. Its name will be the same as the model name, and then it's going to have a set of routes. And so we don't have to handwrite these route names out. We're going to auto-generate them in Q because we already have these routes defined elsewhere as a set of routes. We're going to create, this is what we call the Q function pattern. It's some definition, and it has some sort of input, in this case data model, and some sort of other values calculated based on that. So we're going to calculate resources of type resource, or shouldn't say of type, that unifies with a map of resources or an object of resources. And so for each model in our models, here's end name and m the model. We're going to make a label under resources with the same name, and we're going to assign the model and the name like this, probably redundant because it's there. And then we're going to set up default CRUD routes. So we're going to have a route named whatever, user create or to do create. And it's going to be a post, and it doesn't have anything in its path. And then we have a user read function, and it takes a path param, which is the index field, to our user. And we don't know what this is yet. It doesn't really matter. But we know we stored it this, or that this is going to be the same index that's used in the data store. And then we have update, and that'll take an object which should already have the username on it, so we don't have any parameters. And then delete, we only need the index field for it to do whatnot. And so in order to add these schemas to our generator, we already have a data model from before, so we just pass that in. So the user doesn't even have to specify resources. It's all derived from the data model. These are one of these calculated fields. And then we'll add these resource files. So if you go back here, we now have all 4 of these, or yeah, all 4 of them here. And here you can see where we have, our data model here as this data model here. And this is just a Q quirk. When you want to use the same name on the left and right and it's a reference, you just have to put it in quotes, essentially. Otherwise, it thinks this is the reference to back here. And then what else do we have? We have the resource files. Again, for everything in our resources, we just uppercase it so it stands out in templates. And then, we have this resource template. Again, another like a directory where we just drop all of our resources for this simple example. So what's a resource template look like? Well, we have another one of these route functions that wires it up, right? It's whatever the name is, routes. And this is in a different package, resources. So, all our routes have to have unique names, and all of our resources have to have unique names because they're all going to land in the same directory, as do our types. But as long as our types do, so will our resources because the name's the same. And then we range over the routes, and we end up calling the same template handler we had before. Nothing to do. Like, we get our handlers for free because we already wrote it, and it's reusable. So then all we need to do is then change our router and import the module if there's any resources. That's why we kind of like this, because you might not have any routes, you might just have resources. So that's why we, conditioned it before when you thought, hey, how would you have a API server without routes? Well, we have resources which generate routes, so we can do it that way. Typically, you'll have both, though. And then in the setup router, we just, we had some place where we, right before this, we're setting up our routes, and now we're setting up all the routes to our resources. And the one thing here is where you're going to see we're instead of having a single setup, a single attachment to the group, we're going to have a loop of them, one for each route. So for each, post, put, or post, patch, read, get, and delete in terms of HTTP. So now you can generate this and probably run it, but we haven't written any logic in our actual oh, right, it's a handler, and we don't have any bodies for those handlers, so we need to go into our custom code. And this is where we'll take an example of output resources user.go, right? This was generated for us. If we go, I think if we go in here, nope. Oh, because they are, well, we need to go into here. Because they're a module themselves. Did we not commit the... Let me just show you in the terminal. We need off docs. We'll go look at the code here. So if we go into the code, first example, we're adding a data model. Yeah, it's just not included. So this is, Hoff keeps a shadow directory of the generated content. This is about how it can merge. This is part of how Hoff merges your code plus the generated code together. And as each changes, it can keep merging together, kind of a thing. But if we go look at the output, you'll see here's our go.mod. Go will actually fill in the rest for the indirect dependencies. We have our server here. We already saw this kind of stuff. You look at types. I don't think we've shown the schema for this yet, but we're going to have these user routes. Here's where you see, see post, get, patch, delete, create, read, update, delete. And here's our user create handler. So if we go back here, I don't know if this matches anymore. It does. Oh, I know what I wanted to show. I wanted to show you difference between the two, right? No, that's a type. So this is the generated code here, right? We have a create handler and it's not implemented. And over here, we have a variable and then we bind it onto the context. We're printing it for debug and then we're passing on to user create. So if I suppose if we go back here, that's it. I'm just showing, I left some comments here where you can comment things out, or you could just delete them all together. It doesn't really matter. Hoff will handle this, like you deleting code it generated. And so when it regenerates, it notices that you deleted that code and doesn't include it in the final result. And it'll notice code you added, code you modified. Pretty cool stuff. Just diff3 under the hood. And then there's some example calls here for you. And then the next section, we're going to deal with relations and iterative development. So, we just generated and wrote some custom code. Now we're going to update our schema. And here we're adding relations. This is our custom model from before, where we should just go, I think here. This was, this is the same model where we added just an index field before. We are now adding a relation field. We're going to add a go type as a string. And then based on, well, I guess we also need to look at this. Maybe I should just jump into here. If we look at our schema, right, we have this data model schema and then off schema, right? So this is the full schema. We have a model field, so we want to look at relations. This might look a little different. This is in development. So, a relation in the abstract schema has a name, a relation type, and a type string. And then, so here, for our relations, it's going to have all those other fields, but it's also, we're going to add this go type. And it's going to be a string. And based on one of these relation types here, where, if it belongs to or has one, we only need a single reference back to the other type. This is where we're setting the type of the reverse relation. So if we look at something like user, we're going to have a username, an email, and then a user has to do. So that has, a user has many of the relationship type, which is to do. This right here, you have to be mindful of the strings, that you set for types. In our relation here, this is again the string representation of another of our models. So, for example, we'll look at the data model, right? This is our data model, server data model. Should probably change that name. Models user has an index username, 2 fields of type string. Relations, the relations name is to do, like this right here. And then this is the has many to do. And so this to do right here is a string path to this guy here. And like relations, it has an author, so we're using a different name in the sense completely. And, this belongs to, author represents a relation to user of belongs to. All right, so yeah, we just need to update the schema a little bit. Then we need to update our design. So here's where we're adding those, just the relation area. And then we have our type template. And this is pretty close to before. Here's our fields, and here's where we range over the relations. And here we've just done something different. We've gathered, we grabbed the top level context of dot, which is the entire in object provided to the template, into root, and then that top level type. This matches onto let's see. If we look here, that right there, where's type coming from? Where is type coming from? Type. Oh, I'm looking at the wrong template, aren't I? Route files, type files. There's our capital type, which is the model embedded in it. Just essentially copy all the fields from the model over and then add this ordered fields. I hope that didn't get too confusing. So again, let's do this one before. So we're grabbing this root context, right? And this type here that we see in the template and the dot, that's the dot is really in, and then dot type is this type here. And so we are just grabbing those into some variables we can use other places for shorthand. So again, we just change it so tname and range over the fields, range over the relations. There's that go type. This is the same as before. This is the same as before. All these are the same as before. We're not. Are they completely the same? Oh, yeah. And because we left all these the same, so then for each relation, we're going to create another function called read with. So we're going to read user read with relation.name to do. So that will look like, what that looks like on the outside is types user. If we come down here, user read with to-dos. And so what we're trying to generate based on this data here, this is the relation of an iteration, but we only have one. So we're going to read the user out of the data store based on this index, which is its username. So grab the username. Return an error if it doesn't exist. We're going to make a copy. So this is just a little nuance of how we've done this particular data store. We're storing pointers. If we add the post to the one in the store and then add the author to that, we're getting into this recursive cycle. And when we try to send it back to the user, and it's doing that whole turn the go value into the JSON process that the server does for us, it's going to complain about cycles. Anyway, so then, normally we would do a join here in SQL to find a user and all their to-dos in one shot, but because of what we're doing, we're just gonna look through all the elements in our to-do store and make a local copy for the same reason about pointers and cycles. And then we're gonna say local author name username. So the to-do author, it's a pointer to a user. Does that username equal this username that we just looked up? If it is, we're gonna remove the author pointer if there is one. We just do this to be safe from the user that might be attached to do. Oh, well, because we always do attach the user to a to-do in the store. So when we find it, we want to just set that to nil so it doesn't get rendered. And then for our user that we looked up on line 92, we are going to just append the to-do. And so we'll loop over all the to-dos, and any to-dos this author has written, this user has written, will be added to this copy of the user and sent back. So then if we look at to-do, before we do that, let's go look at the template for this. Because it's looks a little scary. All that code right down there is just this right here. But let's walk through this. So we're just looping over the relations. This is a template comment, so you can add comments about what you're doing in the templates. So we need to look up the model on the other side of this relation. So we have our top level type user. It has the relations, and in this case, we're going to be looking at relation to-dos. User has many to-dos. So we need to look up that. We need to look up the to-dos model. Remember, this is just a string right now. We need to look up the actual model so we know like things about it. And Hoff has this deref commit function for helpers. It's right here. So what we're gonna do is we're gonna try and look up. We're gonna try and deref this path. So our relation type, which is just the string to do, from our root in the data model. So it's going to go into this object, which looks, looks like this. It's going to go into the data model. And it's going to go into models, and it's going to look from there. It's going to try and access user to do. So if we go back, right, this will be the model on the other side of the relation. So again, we're in T, we're in user, model. We're going to look up, the string to do. We're going to look up to do in the actual data of the models, store that in a variable. So now we have that. So then we need to do a second reverse lookup because, well, it's not user anymore, it's author. So that's how we're creating essentially a path here. We're going to, within our model, right, we need to look something up. We're going to look in the relations, and we're going to, for all those relations, we're going to look for something where the type matches something. So we go back here, right? We've got into user, we're looping over the relations, we're in to-dos, we're in the to-dos relation. User has many of these, so it's type to do. So maybe we could do this. Let's put it over here. Maybe I'll just templates. This is a type. We're at the bottom here, right? So again, where this right here, this model, this relations right here is this relation. So R is now to-dos. And so we look up r.type, which is to do, in the root data model. So to do maps to here. So we're in to-dos. And that's what's in M. So then D is a path that we then want to deref this path out of the model, out of this model we just looked up. So what we're doing is we're going to look at relations. And then for every relation, we're looking for the one where this type matches the type we're generating here. So user, bam, here. And this is just reverse name. It's not reversing it. It's a reverse. It's the reverse, T, so user to do back to user. And we just want that. Well, we're getting this whole author object actually out. Once we find one that matches on this type here, we're just gonna, we don't actually just return the type, we return the whole author object. So then what we can do is we can say for our original type, user, read with our relation name, which is read with to-dos. And we're gonna return a user object. And here's where, let's do this. Let's get the output next to this. And hopefully you can fit this all on screen for the most part. Let's shrink that down. We'll make this a little wider. Here, okay, so now we can see it all, right? So our relation name is to-dos. That gets filled in here. And then here's where we're user storing, just building up. That's the same thing as read, just read user. Instead of just returning it, now we're going to loop over the to-do store, make our local copy, and then this is where we're coming back, local author user. This is where we need the local reverse name, which is we're in user. We went through the relations to do's and found to do. So then we went to do, and we need to figure out what does to do call us on the other side of our has many relation. So we find that relation where it's the user, which is us. And we say, okay, so this thing coming out, this to do coming out of here, it's going to have an author, and it's going to have an index field, username, right? T.index is username, which really refers to this. And we're going to say, does that match the data the user we're looking up? Does it match that index field there? And then here's where we set the reverse name. We're looking up something that's related to us, and when we find it, we're gonna delete its reference to us because we're gonna attach it to us, in this append. So we need to like delete that thing that points back at us. We're pointing at it; it doesn't need to point at us anymore. And this is here's where we have this switch here for has many and many to many. That's when we need to do that's when we're going to do an append call here, right? This append. If it's not a has many or many to many, it's going to be a has one or belongs to. So in that case, we're going to do a similar matching. This actually might need the reverse name, I'm not sure. It probably does. I'm not sure if this code is actually being tested. Testing generators is an interesting topic. And in this case, it wouldn't be a slice, it would just be a single object, and we're just going to set to the address of local and then break. Now let's look at the same for to do. Read to do with author. Because we might need an extra condition here of like else if equal our relation type to belongs to, I think, and else here. And this, I think, is the else clause. And then this one is not a belongs to. This is the backwards direction sort of thing. Whatever's being pointed at. We kind of have two sides of a relation. You kind of have to decide which one is kind of owning the other than many to many. Okay, so that's where we can do that. And then, all right, now back to our tutorial. So we've been going through this. We just saw that template, and then we need to add some custom code. So in our read user handler, instead of user read, we're just going to do user read with to-dos, and it just works. For our to-do create handler, our user, when we read a user to-do or a to-do, it's already going to have the user in it. If we go over to if we look at the user read, here, in our read with to-dos, we're deleting that back reference. But if we're only grabbing a single to-do, we want to keep that back reference. So we don't do anything. We don't delete anything here. And instead, or I guess this is the read. And so if we, we read exactly what we wrote. So as long as we store the user on the to-do before we pass it into here, it should be all right. So, we dealt with like filtering on the many on the way out for users and their to-dos and the author reference. What we're gonna do is like deal with adding the user on the to-do create handle, because that's where we have the context. We're gonna add a query param for username. So we're gonna get this to-do in the body, and we're gonna get a query name that's a parameter. And then so this should just be actually just user read. We can get rid of that. But we would essentially just look up the user just like we do in the user read handler. It's essentially same thing. And then we would set the author to that user we found and then just create the to-do. And then the to-do get handler doesn't have to change at all. So we've been able to add in relations with some pretty minimal code here. And there's, we can, I've left adding the actual query param and auto-generating this if you want to. You could just write it here, but it'd probably be better if you put it into the server schema or your instance of this server. And then what we want to do, what we want to do. I left this as an exercise with some hints. Then you can regen, rebuild, and rerun. Try out this kind of stuff. Make a user, make some hello content, get them back. You could delete them, update them. I added some commentary here. I'm expanding on that in this data modeling section. This is the live site. I was working on this earlier today. Anyway, getting back to here, adding a data model, we're at relations, and we just got through that. So now I want to kind of just briefly talk about checkpointing. So one of the things is, we develop our applications as we go along, and our data model changes. So we create a database, we push out something to production, users start using it. We now realize we need to add something to our data model, and we have to make application changes. We have to make changes to the database. And so what Hoff does is it has this idea of checkpointing your data model. So when you're happy with the current state of it, you'll call Hoff DM checkpoint, data model checkpoint, and then it's essentially going to save a snapshot of that model. And then you'll be able to, if you change your data model, you can be able to diff to see what changed. And you can see the history of your data model, and then you can look into it and see the history of changes. So what was the difference between each step? And this is if we're going to generate a series of migrations for a database from your data model, we kind of need to know the history so we know where your database was at various points, and so that when you've updated your model, you don't have to worry about writing that migration anymore. Hoff's going to write it for you. Well, not necessarily Hoff itself. Hoff is going to keep track of the changes to your data model, and then generators can implement those changes, or that change set from go to one version to the next. And that's really, I think, the more powerful way to just feed this information into the system, is that that same diff can be used for generating database migrations, but it can also deal with generating functions that convert from one to another. So you put out version 2 of your application, but one of your users is still on version 1. And what happens is they send a version 1 request, and before it hits the real core of your application v2 logic, there's going to be a shim which translates v1 to v2, and then feeds into this application code. So you don't have to maintain 2 versions of your application or your application logic. You convert old versions to the current version, and then on the way back out, you should hopefully be able to write have a conversion function. Hopefully you're just kind of filtering the data. You really want to strive to not have backwards incompatible changes. And this is something Stripe has done really well. There's we go down to notes and we look at data modeling. There's some Stripe has done this really well. There's this, I think Project Cambria is this idea of data lenses, which is that sort of transformation function. I think that's by some people from Stripe. And there's something like, we'll talk about some of the stuff maybe later. And with this kind of, I can just show you what this looks like. So if we do like a Hoff data model list, you see I have a data model named my models, has 2 models, has 4 checkpoints, and it's currently dirty, and it subsumes, which means this means it's backwards compatible. This is Q terminology, subsumption, which is how Q relates to different values to each other. So, there's an int, and then greater than 10 is a constraint. So that's it's an instance of an int, so it's subsumed. It's greater than 10 is backwards compatible with ints. Like everything that's greater than 10 is also an int. And then like 1, or I guess maybe 20 in this case, would be backwards compatible with greater than 10. It's an instance of greater than 10. So we could do something like what has changed, Hoff DM diff. Oh, well, I guess we decided to add a field username. I thought we had that already. Oh, this is the test. Right. This is, let's look at this file real quick. We're just data model. This is just a standard data model. Other than that, we've packaged up our models here and just passed it in as one thing here, with an embedding rather than a loop. And then so we have a data model. Oops, how did that happen? We haven't seen this yet, but it has Sql Common Fields, which are just a UID created at timestamp, updated, maybe it deleted at. But what you can do is you can package common fields up. And this is using, we didn't see this, but Hoff defines some like default fields like email. So instead of having to write like a string, like what type is it, like what are the like validation rules around it, what are its like database types, things like that, we can just use fields.email and it gets all these sort of default configuration out of the box. And then we have a persona, it's an enum, guest user admin owner. The default is guests. Passwords, is it active with a bool string? We have the basic types, but then we also have like more interesting like application building block types. And so like when you use a field password, the generator is going to say, hey, you got a password type there. I know how to handle password types. They're treated specially. So like when you make it for the first time, I'm going to bcrypt it. And then when you want to like compare it, I know I need to bcrypt and compare the bcrypted versions. So you'll get bcrypted out of the box. And then user has a profile. We haven't actually hooked up the relations in this test data. But we could look at Hoff DM history. You see we have, we've had 4 versions and we're on the verge of our 5th because of, its current status is dirty. We added this username field here. So then we can do, you could also do Hoff DM diff since, these are timestamps, since here. I wonder if that works actually. And until this, what was the difference between those 2 versions? And we'll get something very different. You'll see if we go, you can see this is, let's just do Hoff DM log, which shows, this is our original version. It's 4 back from where we currently are. And at that point, we only had a user. Email, password, inactive. That's all we had. And then our next version, we added a profile, first name, middle name, last name. And then in our third version, we added the Sql Common Fields, which is actually, I guess, 5 fields. We have an ID, which is a UUID. We have a CID, which is a cloud UID, which is a special type of ID that's really designed for generating tons of them at the same time across microservices and still having non-collisions. And like here, we're defaulting to a random UID. This is a function in Postgres. I think that's just like hanging around. And then you see it's the exact same fields on this. And, you know, all we did was add this single line to each of these, and we got all that. And what you'll get soft deletes, these kinds of things out of the box. And then, all right, so we added our fields, and then we added persona, and then the current diff is we're adding a username. So that's kind of what's going on. What else do we have here? We could create a Hoff checkpoint, and that creates a new checkpoint. And then these things are in .hoff data model. And then under your model name, you'll find, oh, I wonder if I have, let's check. Might have, sorry, it didn't actually create the snapshot, which probably means that, where's our library data model? Check, I might be returning early. Maybe not. Not sure what's going on here. Live coding. Oh, sorry. We'll look at these in the here. Since it's the test data, here's our DM. You'll see there's our version 1. And you'll see it's storing, if we go to like one of the middle versions, it's not storing the diff, it's storing the entire data model at each point. And what Hoff does is it actually, when it presents the history to the template system and your generators and all that kind of stuff, when you load a data, when it loads a data model and it finds the data model, it's gonna attach the history, and so it's going to attach each snapshot as well as the diff between the next snap or the last snapshot. Like, here's the current snapshot and what did it add, or remove diff kind of stuff. What I wanted to do was, let's go back here, test data model off DM ls. Let's figure out why this is not working. We'll dig into some code real quick. Perhaps. Okay, it's getting to here. All right. We don't need this anymore. Yeah, it's showing the plus. So it's getting to here. Here's that subzoom line. Oh no, it only shows that if it's, it also calculates backwards compatibility. It does, you can do automatic version bumps. You'll get Hoff DM checkpoint H. You can have a major, minor, or patch bump, or you can provide the semver directly that you want. This is useful if you want to do like 0.0.5-beta 1. But if I do something like 4.beta1, it's like, hey, your version's wrong. 4.beta1 is earlier than just 4 itself. Let's see what's going on. Trying to figure out why this is not returning, or it's not actually writing the file. So here's where we're adding the version to the output, right? Make the dir. Good old print debugging. Okay. File name. By the way, this command just like rebuilds and installs Hoff, so I can rebuild it from anywhere. Oh, did it work that time? I guess so. Are we just in the wrong directory? There's our version 5, so we could go, what we could do is just delete this. If you're ever unhappy, just delete it. And then we'll end up with something dirty. And then what I wanted to show you was, let's go into our test data model user. And then we'll use the username. So now we should end up back with an OK copy. And now what I wanted to show is if we do something like delete a field that was previous there, we can do this and it'll be like, it'll tell you it's dirty and it says required field is optional in the Sql value active. What this is saying is like we removed active, so it was previously required, it's now optional. These messages probably could be in it. Maybe this one's not so bad, but there's some harder to read subsumption error messages. Cool. We'll just add that back, and then we should be able to. Ooh, that's hard to read. About that. It's a little bit easier to read. I think we'll just git check. We'll go up 2 directories, git checkout. Cool. This is some of this work is still, there's a if you want to follow along with this stuff, we are on Hoff beta 2 here. So you can go and just download this version, or you should be able to Hoff update check. Yeah, there's a, you should just be able to, if you already have Hoff, you should just be able to update. You probably don't need the version string. Let's see. Was there much else? So yeah, getting back to what I was originally set out to do today, I think I might cut it off here in a bit. This seems like a pretty good first day. We were in first example, just to get you up to where we are. I just finished this section, and the upcoming sections are this multi-language output where we're going to write JavaScript and HTML from the same server data model and add that front end to work with these things. We'll display all the users, where we'll display a user, all their to-dos. But I think first I'm going to go through this data modeling section. Maybe I could show you what where I'm currently at with that. Oops. This is Hugo. So if we go to localhost, we go into data modeling. We got a bunch of stuff here I'm working on. It's a little more in depth of this data modeling, but first I want to show you how to do some data modeling with Q and generate types. Go into the commands a little bit more than I showed before. Show you the schemas. Probably just I'm gonna make sure they're consistent, but also mark them up a bit. Go into like creating generators specifically for data models and some of the nuances there, and then we'll look at how we can extend. Maybe I should write something about that somewhere. Something about. Sorry, I digress. I have something data modeling. MA extending MD. Title extending. I don't know what weight I want, where I want it in the order. Actually, I do. We probably want it after schemas. Let's guess 15. I'm just making a placeholder for now. Nice. It landed there. Cool. So yeah, then we're going to talk about schemas, how we can extend schemas, how we can make generators for these extensions, and generally from like the vanilla data model and the extended versions of it. And then we'll look at some examples with like how we might extend and generate something for databases, and then for languages like Go and JavaScript, probably maybe Python, but probably not. Like invisible characters and text templating are not fun. Hashtag Helm. We'll go more into the snapshots and history, and how that kind of gets built. Show the details in the docs, what I was just talking about, and then we'll go into migrations and lenses, which is where you sort of combine like these schemas for databases and this like history and snapshots and the diff between them, and that's how you can make migrations and these like lenses that transform between different versions of a type or a request body or something like that. And then we'll look at like how we can compose things together. So we had like a single data model, and then we have specializations for databases and languages. How do we like merge those together so our user only has to think about like one data model that's presented to them, and you've like built somebody else writes an SQL, or maybe they write a Postgres, and you grab the Go types kind of module and you bring them into your server module and sort of bring these things together. So like generators are composable, so are these data models, and then those can feed into generators. So there's a bit of pairing, and then we want to have a section on the complexities of data modeling, things like I think it's over in here right now, some of the complexities. Where did I put that? I don't know where I put this. Do I have it in here? It's somewhere. So the difficulties with generating types from a single like Q definition. How do you deal with public versus private versus protected? Like Go only has public and private, and it's done by casing. Whereas something like Java or C++ has public-private protected. It has this, how do you express different type systems like object-oriented versus structural typing like Go, versus databases, which are more those have relations, and like each of these has composition and inheritance. There's a bunch of like technology or language specific things that somehow you have to capture, and I don't know, like, here's the thing, right? Like, you could add attributes to your Q code, but you need a tool that reads attributes because you can't read them yourself in your Q. They're not part of the evaluator. So we somehow have to, and like, the whole reason Hoff exists is because if I wanted to, I'm generating Go types from Q. Well, now what if I want to generate Java types? Like, how do you make that happen? Do you have to modify Hoff? Are you generating Go code based on like, how do you put together the text that goes into a file that's going to be read by the Go compiler or the Java runtime? And so Hoff is, the core thing has been remove the schemas from the tool, so you don't have to modify Hoff CLI and the command line tool to make new schemas and data models and combine them in interesting ways and make modules. And on the same side, you could do the same thing with generators. Like, how do you turn a schema into a Go type isn't defined in Hoff itself. It's defined in the things Hoff reads. So you, as somebody who wants to use Hoff, have a ton of flexibility in both sides of that, and how you set up like what can a user write, and then how do you turn what a user wrote into code the user wants to run. And that's where I probably need to go back and go through the table of contents and such things. Anyway, I am going to wrap this up here for now. I'll probably cut this as the first in a playlist of some sort, or at least a video like introduction to Hoff and Q, something like that. And I hope you have a good one and come try it out. Join Slack. You can go to Slack here. I'm not gonna pull Slack over, but we have Slack, we have GitHub. I'll probably be like, if you want to jump on like like a Google Meet or a Zoom session, I think I'm gonna do streaming sessions where you can come and ask questions, and if you want to get on and ask over words, we can set up a room. Maybe we do it right through. Not sure if we can do it through Slack. Either way, I am on Twitch right there. And if you get to Slack, Twitch and YouTube, it's going to be on both of those. I'm going to stream to both for the foreseeable future at the same time. And YouTube will save these. So if you miss any, be sure to subscribe on YouTube, follow on Twitch, get into the Slack, and you'll get all the notifications, start chatting. We'll have a good time with Hoff and Q. All right. We'll see you later.